let's take a look at a few rules. Let's first start off with the power rule. The power rule says the following. The derivative of x to the n with respect to x is nx to the n minus 1. The power rule combined with the chain rule says the following. The derivative of g of x to the n with respect to x is n times g of x to the n minus 1 times g prime of x. The directions say to find the derivative of the given function. Let's take a look at number 1. Suppose f of x is 1 plus x squared to the 99th power. Now, my inside function g of x is 1 plus x squared. G prime of x is 1 plus 2x. So if I put all this together, f prime of x is equal to 99 times 1 plus x squared raised to the 98th power times 1 plus 2x. And that right there is example 1. Let's take a look at example 2. Suppose I'm given f of x is equal to 1 over the cube root of x squared minus 1. Now, let's simplify this a little bit. I can write this as 1 over x squared minus 1 raised to the 1/3 power. And I claim we can go a little bit further than that. So I claim capital F of x is equal to x squared minus 1 raised to the negative 1/3 power. Now, my inside function g of x is equal to x squared minus 1. And if I take the derivative, I get g prime of x is equal to 2x. And so f prime of x is equal to the following. You get negative 1/3 times x squared minus 1 raised to the negative 4/3 power times g prime of x, which is equal to 2x. And we do need to simplify this a little bit here. And so f prime of x is equal to, now, in the denominator, I'm going to get 3 times x squared minus 1 to the 4/3. In the numerator, I get negative 2x. And that right there is how you do example 2. Let's take a look at example 3. Suppose f of x is equal to the square root of 5x plus 1, which can be written as 5x plus 1 to the 1/2 power. Now, my g of x is 5x plus 1. That's the inside function here. If I take the derivative, I get g prime of x is equal to 5. Now I can put everything together. So f prime of x is 1/2 times. Now, again, my g of x is 5x plus 1. And I'm going to raise this to the negative 1/2 power. And I'm going to take this result and multiply by g prime of x, which is equal to 5. And so this is 5 over 2 times 5x plus 1 to the 1/2 power. But one thing to take note of, notice in the original problem, we started off with f of x is equal to the square root of 5x plus 1. So I'm going to rewrite f prime of x as follows. I'm going to rewrite this as f prime of x is equal to 5 divided by 2 times the square root of 5x plus 1. And that's how we do example 3. Now, before we embark on examples 4 and 5, I want you to recall the following. I'm going to go over one specific rule here. So the derivative of cosine of x with respect to x is equal to negative sine of x. Now, if I take the derivative with respect to x of cosine of f of x, well, I get the following. I get negative sine of f of x, and I'm going to take this and multiply by the derivative of the inside function. In other words, I'm going to multiply this by f prime of x. You can think of this as like peeling an onion, so to speak. So if we take a look at example 4, suppose I'm given f of x is equal to cosine of x squared. My g of x is x squared. That's the inside function. If I take the derivative of x squared with respect to x, I get 2x. So f prime of x is equal to negative sine of x squared, and I'm going to take that quantity and multiply by 2x, which is negative 2x sine of x squared. And again, that's equal to f prime of x. That's example 4. Now, in example 5, this is very, very subtle. Suppose g of x, we'll call it g of x, is equal to cosine squared of x. And I'm going to write this as cosine x raised to the second power. Now, since g is already taken, my inside function happens to be cosine x, okay? So what I'm going to do is I'm going to let h of x equal cosine x. If I take the derivative, I get h prime of x is equal to negative sine of x. Now I get to put things together. So g prime of x is 2 times cosine of x raised to the first power multiplied by h prime of x, that the derivative of the inside function, in other words. So I'm going to multiply by negative sine of x. And so this is negative 2 cosine x sine x. Now, hopefully we should be able to recognize this as the following. We should be able to say g prime of x is equal to negative sine of 2x. And that right there is example 5. Let's take a look at example 6. Suppose I'm given y equals e raised to the tangent theta. Okay, I'm going to come over here and I'm going to do a quick recall over here. the derivative of e to the x with respect to x is equal to e to the x. The derivative of e raised to the f of x with respect to x is e to the f of x times f prime of x. Now we're in a position to figure out the derivative of e to the tangent theta. Now, I'm going to let f of theta equal tangent theta. So f prime of theta is equal to secant squared theta, right? And so dy d theta is e raised to the tangent theta times secant squared theta. And that's example 6. Let's take a look at example 7. Suppose I'm given the following. Suppose y equals x squared times e to the negative 3x. Now, there's a product rule in here combined with a chain rule, okay? Now, what I want to do first is I want to figure out the derivative of e to the negative 3x. And so I'm going to let f of x equal e to the negative 3x. So we're just going to pull this off to the side, okay? Now, if I want f prime of x, I'm going to get e to the negative 3x, right? And I'm going to take this result and I'm going to multiply by the derivative of negative 3x with respect to x. So in other words, I'm going to multiply by negative 3. And so this can be written as negative 3e to the negative 3x. And I am now ready to take the derivative. So dy dx is equal to, now I'm going to write down the first function, which is x squared. And I'm going to multiply by the derivative of the second function with respect to x. So in other words, I'm going to multiply by negative 3e to the negative 3x. And I'm going to go plus. And then I'm going to differentiate x squared with respect to x to get 2x. And then I'm going to multiply by e to the negative 3x. Now, what we need to do from here is we need to factor out an e to the negative 3x because that's what's common to both terms. But I also notice if we look at x squared and look at 2x, I can also factor out an x. And when I write the leftovers, I'm going to get negative 3x plus 2. And again, this is equal to dy dx. And this is an example of combining the product rule and the chain rule all in one. And let's take a look at example 8. Suppose I'm given the following. Suppose g of x is equal to x squared plus 1 to the third times x squared plus 2 raised to the sixth. Now, again, if it's overwhelming to look at the product rule and the chain rule all in one shot, let's break it up a little bit. It doesn't hurt. So we're going to look at first, we'll call this f of x is equal to x squared plus 1 raised to the third power. So if I want f prime of x, I'm going to pull the 3 out in front. I'm going to multiply by x squared plus 1 raised to the second power. But don't forget, I have to take the derivative of that inside function, which is 2x. And so this can be written as 6x times x squared plus 1 raised to the second power. Now, let's do the same thing for this piece. And I'll let this be h of x, which is x squared plus 2 to the sixth. And if I want h prime of x, I'm going to pull the 6 out in front. I'm going to multiply this by x squared plus 2 to the fifth times 2x. And so this is 12x times x squared plus 2 raised to the fifth power. Now I'm ready to pull everything together. Okay, so let's remind ourselves that g of x is equal to x squared plus 1 raised to the third times x squared plus 2 raised to the sixth. And I want g prime of x. Now, I'm going to copy the first function, and I'm going to multiply by the derivative of the second function. But the nice thing is we don't have to reinvent the wheel. We already did this over here. Now, the derivative of the second function happens to be 12x times x squared plus 2 to the fifth. Then I go plus. Now, I'm going to differentiate the first function, which is 6x times x squared plus 1 to the second. And then I'm going to multiply that result by the second function, which is x squared plus 2 raised to the sixth power. Okay. Now, the question becomes, what's in common? Because we have to factor out. Now, between x squared plus 2 to the fifth and x squared plus 2 to the sixth, I'm going to factor out an x squared plus 2 to the fifth because 5 is less than 6. Between 6x and 12x, I'm going to factor out a 6x. Between x squared plus 1 to the second and x squared plus 1 to the third, notice that 2 is less than 3. And so I'm going to factor out x squared plus 1 to the second power. Now, what do you get in parentheses? Well, I factored out an x squared plus 1 to the second, so I know I have an x squared plus 1 left. And I'm going to take that result and multiply it by 2. I'm going to go plus. I factored out x squared plus 1 to the second and x squared plus 2 to the fifth. So I do know I have an x squared plus 2 left over. So I need to write that down. I didn't factor out all the x squared plus 2's, so to speak. And then all I have to do is simplify this a little bit. So I get 6x times x squared plus 2 to the fifth times x squared plus 1 to the second times. And then 2x squared plus x squared is 3x squared. 2 times 1 plus 2 is equal to 4. So I get 3x squared plus 4 inside those brackets. And that's example 8. So it's product rule combined with chain rule. Let's take a look at example 9. Now, in example 9, suppose we get the following. Suppose f of t is equal to 3t minus 1 raised to the fourth times 2t plus 1 raised to the negative 3. Okay? And I'm going to write this as 3t minus 1 raised to the fourth divided by 2t plus 1 to the third power. Now, this is a chain rule combined with quotient rule. Now, just so we don't get overwhelmed with this, I would look at it this way. Now, f of t is 3t minus 1 to the fourth. And I want f prime of t. Well, this is going to be 4 times 3t minus 1 to the third times 3, which is 12 times 3t minus 1 to the third. All right? Now, my g of t is equal to 2t plus 1 to the third. Double checking? For sure. Now, g prime of t is 3 times 2t plus 1 to the second times 2, which is 6 times 2t plus 1 to the second. Now, we did all the hard work, okay? Now, f of t is equal to, I get 3t minus 1 to the fourth divided by 2t plus 1 raised to the third. And I want f prime of t. Now, my bottom function is 2t plus 1 to the third. Now, let's go back, and we want the derivative of the top function. The derivative of the top function is 12 times 3t minus 1 to the third. So I'm going to multiply by the derivative of the top, which is 12, again, times 3t minus 1 to the third. I'm going to go minus, and then I get 3t minus 1 to the fourth. That's the top function. And then the derivative of the bottom function is 6 times 2t plus 1 squared. And then I'm going to take that whole thing and I'm going to divide by 2t plus 1 to the third, all raised to the second power. Now, so f prime of t equals. Now, I see a 2t plus 1 squared and a 2t plus 1 cubed. So since 2 is less than 3, I'm going to factor out a 2t plus 1 squared. Between 3t minus 1 to the third and 3t minus 1 to the fourth, I'm going to factor out a 3t minus 1 to the third. Okay? Because 3 is less than 4. And between a 6 and a 12, 6 goes into 12, so I get to factor out a 6. Now, the question becomes, what's left over? Now, I didn't use up all the 2t plus 1s, so I do know I have a 2t plus 1 left. And then 6 goes into 12 2 times, right? So I'm going to write that. I'm going to go minus, And then I factored out a 3t minus 1 to the third, so I do know I have a 3t minus 1 left over. So I'm going to put 3t minus 1 in parentheses. And I'm going to take that whole thing and divide by 2t plus 1 raised to the 6th power. And so let's take this a step further. F prime of t equals. Now, in the denominator, I have 2t plus 1 raised to the 6th. In the numerator, I get 6 times 2t plus 1 squared times 3t minus 1 cubed. Inside the brackets, I get the following. I get 2 times 2 is 4, so that's 4t minus 3t, which is t. And then 2 times 1 is 2. A negative times a negative is a positive, so essentially I'm getting 2 plus 1, which is 3. So I get t plus 3. And one last step, I can say f prime of t equals. Now, in the denominator, I get 2t plus 1 to the 4th. In the numerator, I get 6 times 3t minus 1 to the 3rd times t plus 3. And that's pretty simplified. Okay. That's example 9. Let's take a look at one last example for this video. So in example 10, suppose we have the following. Suppose we have, we'll do one like this. F of t is equal to 2 raised to the t cubed. Now, let's recall. The derivative with respect to t of 2 to the t is 2 to the t times natural log of 2. So f prime of t, so if we do the chain rule, we get 2 raised to the t to the 3rd times natural log of 2, and I'm going to take that quantity and multiply by 3t squared, because that's the derivative of t cubed. And so f prime of t is 3t squared natural log of 2 times 2 raised to the t to the 3rd. And that'll do it for this video. And this is a video on the chain rule, and we did 10 examples. Okay.